What's up? So I wanted to record this video for a while. I tried to record it on Friday and failed. So today I'm gonna do my second attempt at the day 3. And I won't dive into the prime statements because I think you can just do that by yourself. I will share the link. But the overall idea is that we have wire. We have a specific way to describe the path of the wire. We start from a specific like the same coordinate for two different wires, and the idea is to find the intersection between the two wires. So if one wire is intersecting with itself, we don't care about that. However, if two wires are intersecting, we really care about this specific intersection. And then the idea is to find the distance of this intersection between the the beginning of the path of the wire and the intersection itself. So what we're going to do is we're going to take this intersection and mark it as the center of our coordinates, and we are going to describe the segments. We're going to parse the segments from that, and from then on we are going to check the different intersections and finally find the distance between the intersection between the beginning and the position itself. And that's it. Let's just get going. So we have this input. This is going to be actually this is not going to be the first input. What we want to do is to take this very simple example, and what we're going to do is we're going to use take.io to run our snippets of JavaScript. I used to do that in the developer console of the browser, but it has several limitations, and in the end I don't feel like the experience is really good. So maybe I will try to increase the size of it a little bit so that it can be comfortable for everyone. Okay, for some reason don't seem to click here. Hope everything is going well with the Zoom with this website so that we can just get in the right conditions and get going with some fun code. Yes, so this is the input. So now, because we are not declaring the variable several times, we can use const. In the previous episode of this series, I couldn't really use const and let because I was running several snippets several times. So here we are just at home. We can use whatever we want. Now what I'm going to do is I'm going to do create a function parse, which takes a line and makes it into something that is a list of segments. So this is it, and what we want to do is use this and parse it into segments. So how do we do that? We just take the line, we split that with a comma. Yeah, we'll just try to use some new features. I won't put the parentheses here. Feel free to let me know if this is something that is weird or if you don't care. So I will assume that you don't care, and I will start with that. So we split, and then we have those numbers. So next thing that we do is we map, and we have R8, for example, or U5 or something else. So what we call it, tuple. We call that tuple. And letter, const letter is equals to so here we have to array. So here we split this into an array of characters, and then the letter is array.shift, and the position is parse int of array, which is the remainder. So here we should have R, and here we should have 8, or if this is remember if it would be 89, we should have that the integer 89 in position. Okay, let's keep the input from the example. And now what do? We should return the new position. So what I would do is I would start with let's not do const. We should just do let position is x is 0 and y is 0. So the idea with this variable is that we are considering this as the position 0, 0. Yep. And now this is the new position, next position. And we have to do a switch on the letter, because here, depending on the letter, we are going to move in a different direction. So we have U, let's just write so no, next position isn't the right way to call this variable because this is super confusing. Here, this is actually the distance. So the distance of where we move. So up, what happens is that we do position that x. Let me think about that. Position that y. So this is going to be the. Let me show that here. This is going to be our y-axis. Y-axis. And here this is going to be our x-axis. This is very important to set this because then we're going to assume this is the way we coded all of our segments. So for example here, because we go up, we have to subtract the distance from the position y. So I can repeat this just several times. Oops. 4 times to be honest, to be exact. And if we go down, we need to add distance to position y. If we go right, we have to add the distance to position x. And if we go left, we have to subtract the distance to position .x. This is correct. What next? So here we have our new position that is stored in here. So we have to add a new segment. So segment.push. I would call this from. That should be. So here we're not doing the right thing. Const next position is equals to position dot x position dot y. Let's try to write it that way. We'll see. And here, actually, maybe I could just do dot position. Let's see. Let's see. We're just trying a bit of JavaScript. So from segment.push. So from this is position. So once again, dot position, and 2 is the next position. And then we do position equal next position, so that we advance to the next position. Wow, that's a lot of code written already. Let's try to just console log. And here we parse. Let's just put this. Oops. Let's just do in terminal mode. It's looking a bit nicer like that way. Okay, so I made a mistake. First mistake. This is just very simple, but needs to be fixed. Okay, that's better. Sorry for the noise. Okay, so three dot position is not working. I will just give a quick peek at the doc. No, let's just do position.x and position.y. That should work. Let's make sure it is working actually. Nope. Okay, so we have to just go the old way. That's it, like this. So I'm not doing next position equals position, otherwise we would be copying the object and we would be modifying position in here. So I'm just copying the values so that we can modify next position without modifying position. This is really important because we need here to have both position and next position. So here I will just run it, but of course it doesn't work in here. So we need to do the same, x position.x, y position.y, and 2 is something similar, but with next position. Okay, so here we don't, one thing that I just noticed is that we don't return segments at the end of the function, which is annoying. Now it should be better. So here we should have fixed all, never mind, we don't have fixed everything, we haven't fixed everything yet. Okay, so there was a mistake, I put segments without an S, well, I should have put an S. Okay, so R8 is between the position 0, 0 and the position 8, 0. Between 8, 0 up 5 points. So x minus 5, yes. Oh, sorry, y minus 5, that's perfect. And then here left 5, so x minus 5, that's perfect. And then d3 down 3, so it's y plus 3. So it's here y minus 2. So this is all right. We've done a good job with this function that help us translate one wire description into a list of segments. So this is not solving the problem, because if you remember correctly, we have this weird input that should be the path of our wire, and then we need to find the intersections of the wires. So what we're going to do is we're going to keep that in here, and we are going to go with a function solve. I think that's perfect to describe what we're going to do. So first of all, we're going to do const wires input.split with line return. Okay, so here we have one wire and two wires, and then we map wire to parse wire. Okay, so here in the variable wires we have our two wires that have been parsed using the parse function here. So now we have two lists of segments. So this is really good. I think here we can already switch it instead of parse to solve and to input. So here, let's just console log just to see a bit the progression of what's happening. Okay, so I think I should do const debug. Whatever. Thingify. Let's just do it like that. Variable null2. Okay, so this is just a helper function that's going to be helpful for us. Let's just call it print. It's going to feel easy to use, and like this it allows us to output a JSON using JSON.stringify, which is printing the JSON, prettifying the JSON so that we can see all the variables in there. Yep, I don't think we need to dive more into that. We just have two wires. Now what we need to do is to find the intersections between those two wires. So the only way to do that, I believe, is to do O of n square algorithm to solve that, which is we take the first wire, so it's position 0, and we map wire 1. Sorry, this is not wire 1, this is segment 1. We take the wire, no, the second wire, which is at the index 1. It gives us the segment 2. And let's not forget, I'm just adding the semicolons just as a habit. And here, this is the interesting part. We're gonna have to know, are those two intersecting? So intersection check. So this is where this is happening. We can write a little const intersections here that will receive all the intersections. Okay, this is good. So here, this is what's interesting. We are going to have two segments and we are going to check whether they cross each other. And the first thing to do is to check, in my opinion, to check, are they actually in a cross? So meaning we need one segment to be horizontal and one segment to be vertical so that they cross. Otherwise, if two segments are horizontal, they will never cross, or they will always cross, and I believe this is not something that is intended in this exercise, in this puzzle, sorry. So how do we do that? We take a segment 1. What I'm like to do is to check whether segment 1 from x is equal to segment 1 from 2x. Yes, this is how we define. And here we're going to use a XOR. I will explain why we are doing that in a second. So this is segment 2. So here I am using a XOR in here because I want either the segment 1 to be horizontal. This is the check to check if the segment is horizontal. I just check if the from x and the to x is the same. It means that this is this is vertical. I'm sorry. So I'm checking if this is vertical here, and if this is vertical, then the segment 2 shouldn't be vertical. And if this is horizontal, then the segment 2 should be vertical. So this is the idea of the XOR. So this is why we are using here, because this is perfect. Then when we make sure those two segments are like this, we need to make sure they are crossing. Now, this is where the interesting part is coming. So I'm using a nested if because I don't know exactly what's happening, but I could simply add more conditions in here. But for now, I'm just using a nested if, just because I'm not sure exactly what I'm going to put in this if. So first of all, we need to make sure, let's draw something. So we have one segment that is horizontal and one segment that is vertical. So first of all, we need to check that. Which one is which? So what I'm suggesting is to do const vertical. It's so we said if this is the case, then the segment 1 is vertical. Otherwise, this is the segment 2. And we're just going to do the same here, horizontal. So I know that only one segment can be horizontal and one segment can be vertical. So this is why I'm using the same condition, and I just have those two options. So now the cool stuff is starting. So we need to check that the vertical segment, oops, why did I draw this? The x here is below x1 and x2. So if vertical dot from x, so here we don't care if this is from or to, because the vertical, like as we said, both from and to are equal. So this one should be more or equal to horizontal dot from the x. Oh, just noticed something. So we don't know if the segment is going this way or if it is going that way for the horizontal segment. And what we care is we care about this point. So what we need is to take the minimum between this and this. Whoops. Whoopsie. So const min x math.min between, okay, this and that. So vertical from x should be between min x and vertical from x should be below or equals, let's call it max x, which is exactly the same as here, except this is the max. Okay, so now we know that this is min x. I don't know if maybe I can write here. That's great. This is the first time, one of the first time that I'm using this tool, and this is going to be great here. Min x, and here this is max x. Perfect. So yeah, we've got something that should be working. However, so here we just made sure that the segments are either, whoops, let me go back to drawing. Actually, maybe let's clear a bit the board. Whoop. Feel a bit like a teacher right now with these old blackboards. Okay, let me get back to that. So we made sure either we have a segment that is like that, or we have a segment that is like that. So we now we need to make sure the vertical segment is the y min in here, y min and y max. So we need to make sure this we have this y that is between y min and y max. This is the next step. So let's just copy paste that. So we have min y and max y, and in order to get that, we need to have the y of the vertical segment. So let's do a lot of copy paste. Oops. Okay, so we have min y and max y. So we need to make sure now this is the horizontal y. So horizontal dot from dot y. One more time, here we don't care if this is horizontal from y or horizontal to y, because as you can see here, both this point and this point are on the same y. So this one should be above or equal min y, and horizontal from y should be below or equals max y. And in that case, we are good. We've got an intersection point. And how do we put it, this intersection point? Intersection. So what I'm suggesting is I won't create an object. Let's create an object. Let's do things correctly. X, so I'm just putting a placeholder for now. And here, this is the interesting point. So we need to get the y of the horizontal segment and the x of the vertical segment. This is what we need to get. So the x of the vertical segment, we said vertical dot from dot x and horizontal dot from dot x and dot y. Very important. Those are like the typical error that you could make. Just stop paying attention for a second, and that's it. Your algorithm just goes to waste, and you have to spend hours debugging. Okay, hopefully we are good. So here, like for example, I didn't pay attention. Intersections dot push. This is what we need to do, because intersection is an array. It has an S, and we need to push a new point in the end. So we're just gonna go and print input, or we can actually just return. Let's return input, and here we're gonna call print. Let's see. Sorry, I'm stopping to pay attention. That's not good. We shouldn't return input, but we should return intersection. Of course, this is what's interesting in this example. Okay, so we have 1, 2, 3 intersection points. However, they are just sharing 2 intersection points, which is this one and this one. So let's check this one. It is at 1, 2, 3 x and 1, 2, 3. So minus 3 and 3. Minus 3 and 3. Yes, that's correct. And let's just take this one, 6 and minus 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, 2, 3, 4, 5. Okay. This should be good. Yes, it is correct. So we are good for the intersection. However, we just have this intersection, which is theoretically it isn't correct because this is this point. However, I remember reading that this points. I cannot find it. Yeah, okay. Here, this point doesn't count as a crossing, so we can remove that. So we're just gonna filter p dot x is not 0 or p dot y is not 0. So if both of them are equal to 0, then the point is going to be filtered out. Let's try it. Up. I forgot to type the 0. I was seeing the error in here, and I was wondering why there was an error, and now I know. Okay, so we may manage to remove the point that we don't care about. So this is all good. However, I believe this is not what we want. What we want in the end is the distance. So let's do that. Here we filtered so that we only have the correct intersection points. And actually, no, that's good, that's good. Let's keep that. Then here we're going to do map points P to the distance. And the distance is the absolute of P of X plus math.absolute P of Y. This is the nothing crazy, just the definition of the Manhattan distance, and this is between the point X and the point 0. So here it's just like p of x minus 0 and p of y minus 0. So yeah, we can just remove the minus 0. And here we want to sort that so that we have so that the distance const sorted distances, so that the distances are sorted in the ascending order. And then we just need to return sorted distances, like the first sorted distance. Actually, I don't really like the sorted function, so we're just going to do like this, distances, and we're just going to do a math.min distances. So we just return the minimal distance. That's it. And this did not work for us because we forgot the 3 dots, which are translating this array into a list of attributes for the math.min function. So the distance is 6. Let's see what was expected. This is 6. This is correct. So now comes the interesting part of taking this input and seeing whether we have 159. Let's see. Let's just put it here. And let's run things. 15. I believe this is not what we expected. 159 was expected, and we get 15 in here. So we know for sure that there is a problem somewhere, and this is where the fun begins, or ends, actually. Let's see right away. We are going to print the intersections. Typing error. So we have, yes, so this intersection is later on removed here. And we have those 4 points. And let's see again in here, 159. So for sure there is something weird happening in our code, because 159 is a very big distance compared to all the intersection points that we have that are distance 16, distance 18, and distance 15. So there is something weird happening. Let's go slowly. I think the first step is to just display this here. So console log json.stringify wires. So what I'm doing is that I am outputting the complete wire. I'm going to make this bubble smaller so that I don't get in the way. So let's see. So this first wire is going from 0, 0 to 7, 0. If we look in here, we see that this is 75. So we have definitely an error in this function. Let's make this bigger and see where our error is. So here, I can already see it. So here we split this R75 into 3 characters. We take the first character away, so we just have 7 and 5 in the array. Let me make myself bigger again. And here we pass the array, which is just passing the 7 as an integer. So here we should actually do dot join, which is compressing the array back together, and here we should have 75 again. Let me remove this console log and just do as if there was no error. 159. Let me remove that as well, because this is just debug stuff. Feels good. Feels good. We have 159, which is exactly what was expected from us. Here we're gonna print the second example. sorry, we're going to use the second example, 135. Let's see. 135. Yes, feels good. Let's check the input of the puzzle. And we're going to copy paste that right here. Oh, this is a lot longer here, as you can see the scroll bar. So 258. Now the next step is to take that, and the moment of truth is now. Is it gonna work? Yes! So I'm really happy to say we have one more gold star in the Advent of Code 2019. And yeah, if you like what's happening so far, feel free to drop a like, it helps a ton. I'm gonna pause the video now and get back to you in a second. And we're back. So I've taken a couple of seconds to read this problem statement, and I think we coded our solution for the first part of this problem in a good way to help us solve this. So we have to compute the number of steps each wires take to reach each intersection, and we need to choose the intersection where the sum of both wire steps is the lowest. So this is really good. What we're gonna do is we're gonna go back to, no, we're just gonna take this example, we're gonna put it here, and we're gonna change slightly bit our solve function to make this work. So here, instead of just having the segment, we're also going to have to take the position of the segment, position 1 and position 2. The good thing is, because we use a map and we have all the segments inside of an array, we know the position of the segment in this array, and this is going to help us know the number of steps the intersection is at. And we're going to simply have intersection.push here. Because we used an object, this is really good because we can add another attribute, which is the number of steps we took to reach this specific position, and I believe this is position 1 plus position 2. Yes, I believe this is what is needed here. And let me see. Here you need to get the smallest amount of steps it takes to reach the intersection. So instead here of taking the so we still discard the intersection that is at the position 0, 0. Of course, we don't want to count that, and instead here of using the distance, I'm gonna just comment out this, and I'm gonna write a new line. And here we need to take just the number of steps. So this is just p.steps. And let's try to solve that. This is 10. Let's see if this is correct. I'm not sure. No. Nope. This is not working. Yeah, so we have here, we should have 610 steps. Let me see. So what do we need at the end? We need to minimize the signal delay. So the sum of both wire steps is the lowest. Okay, so we have an issue because we have 10 instead of 610. That's not good. So we get back to the drawing board, and I believe the intersections are correct. What is not correct is the steps it takes to reach this specific intersection. I think we're just gonna print intersections here. Let's see. Okay, so as you can see, x0, y0, step 0. So this one is always just, we get rid of it at this stage, so we don't need to consider that. Considering the other parts, step 10 is something that comes back very often. So I believe there's something with the position that is not working. I believe this is not the number of segments, but the length of the segment. Let's see. Number of steps it takes each wire to reach each intersection. Yeah. I think this is, yeah, of course. Here you can see the central port is reached after 8 plus 5 plus 5 plus 2. So here this must be 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5 plus 2. Okay. So now I understand I made a mistake. I still need to keep this. We still want to have the intersection that is the closest to the center, if I'm correct. I'm not sure. Oh, wait. Okay. 7 plus 6 plus 2. So this is going to be this intersection. This is going to be... Okay. So, instead of steps here, this is not position 1 and position 2. I was mistaken. This is not the position in terms of segment, but this is the position in terms of steps. And here, the only way to do that is to have current steps for the wire 1. Oops, this should be something that we increment, and current step for the wire 2. Okay, so this is what we do, and what we need to do is, after we went through a specific segment, we need to increment the current step. So for example here, just before we go to the next segment 1, we need to increment the current step 1. How are we going to do that? We're just going to do the distance. So math.apps segment from x minus segment 1 from .to x. So this is the Manhattan distance. Oops. Let me just keep my head here and just go to line go to a new line. And here we need y and y. So this is the Manhattan distance. And we're going to do something similar in here for the current step 2. You know what? I think I should do, that would be a lot better to have a const distance, or let's call it Manhattan. Is that how you spell it? Let me make sure. Manhattan. Yeah, I think that's good. Perfect. We go back here. Manhattan, 0.1, 0.2, and then we're just going to do math apps 0.1.x minus 0.2.x, and we do plus this with the y. This is intense. I feel like the day 3 for me is a lot harder than the day 1, day 2. Which is good. This is good. Segment. Oh, let's remove that. Segment 2 dot from segment 2 dot 2. We do the same for the segment 1 now. We are getting super close, I believe. And now the steps is current step 1 plus current steps 2 plus, and this is where things get interesting. So what I'm gonna do, this is so much code changes. Now, what we need to do, so we have all the sum of segments until the segment 1 and the segment 2. So we need to take to add some steps here. I.steps plus equals between the segments, the distance between the segment 1 dot from and the point I, plus again between the segment 2 and I. So what's happening, let me take this, or maybe here it's going to be interesting. So what I'm adding right now is I am adding this specific point here. So this point and this point. So the current step is counting this and this and this and this, but then we also need to include the partial segments until the intersection. So this is what's happening. This is what's happening here. I'm adding the partial segments until EI, which is the intersection. Okay, now we should have everything in place, and we won't want to transform the list of intersection into the list of distance, but yeah, we need to have p.steps as we wrote previously. Let's try one more time and see what happens. Okay, so I made a mistake here. Distance is not defined. Okay, so instead of distance, this is Manhattan. Yeah, I was hesitating between the two variable names for the two names for the function for the distance. So that's why I'm mixing things. Okay, so let's see in the end. Let's get rid of this. Let's run that. 610 steps. This is correct. I'm getting excited. Maybe this is the end. Is that correct? 410. Oh, this is good. This is good. Let's get the complete puzzle inputs. Paste it in here and run that. And get this number that is a very high number of steps. Let's see, is that correct? Yes, that is good. This is it. This is it. We've managed in this video to get 2 stars in the day 3 of the Advent of Code 2019. If you liked this, feel free to drop a like. Feel free to write comments at any time in the video where if you have some questions, I will be super happy to answer them. Feel free to drop a like, comment, and subscribe so that you give me a lot of energy to create more of those videos. If this is something you like, I will be super happy to create more of these videos. So we are like losing a bit of time, meaning like the days are going faster than the number of video I am releasing. I'm just trying to keep making a couple of videos, but I might not be able to reach the day 25 on the 25th of December. We'll see. Drop a lot of likes so that I can record more videos. Thank you very much for watching until this point, and see you in the next video. Bye bye.